So, as I said, the project that we're leading, that I'm leading, is called Foundry, which stands for Foundations of Robustness and Reliability in Artificial Intelligence. Now, what does this mean? We are pretty used today to applications like ChatGPT or, for instance, Netflix recommending movies when we want to relax after a hard day's work. But AI has also much more important and less and more subtle applications, like for instance in self-driving cars or even admission to hospital. And these applications can actually have a very catastrophic event, can be very catastrophic if they go wrong. So for instance, if a self-driving car misidentifies the stop signs like a go sign or does not identify it at all as a stop sign, it will go through and it will cause accidents. And this is not something which is theoretical, this is something which has taken lives in the US, where such technologies have been deployed, and this is a real problem. And likewise for hospital admissions, if an AI algorithm which is there to aid hospital staff decide who is to be admitted, who isn't to be admitted, which situations are crucial, etc., urgent rather, and it goes wrong, it can lead to loss of life. So these are a lot of applications that are now rapidly becoming pervasive, and we do need AI algorithms that can be robust, safe, and reliable. And in the grand scheme of things, this is what we are trying to do in the Foundry project. So the problem, so to speak, with current AI and machine learning systems and architectures is that they are very, as we say, data hungry. They require a lot of data to be trained, to be deployed even, and they are also sometimes very brittle, very sensitive to the input. You change a bit the data that you use to train them, and the predictions or everything else changes a lot with it. This sensitivity is one of the things that we want to robustify against, in a sense, and this is what is sometimes known as taming the known unknowns, because this is a known problem. We want to be able to build robust and safe algorithms against such issues. The other thing is, or rather, the second main challenge is what we call taming the unknown unknowns. And what are these? These have to do with the fact that, again, AI algorithms and systems are going to be deployed in environments that change in a completely unpredictable manner from one day to the next. We have no idea how the urban landscape, for instance, will evolve from one day to the other, and we need algorithms that are going to be able to evolve in an online adaptive fashion to that. And this is the second main challenge that we're trying to overcome. And putting these things together is what we call being robust in the presence of concurrent objectives, because oftentimes these two challenges clash. We have competing objectives that we need to provide a trade-off for, and designing algorithms that are robust to these trade-offs is like playing a sort of a game between these two challenges. Not always a zero-sum game where one of the two has to lose, but a game nonetheless. And we're trying to use also game theory to address these types of challenges. All right. So one of the main applications that we would like to target, and this is more of an example of an application, is for instance what I said before about self-driving cars. I mean, developing systems that can robustly and reliably identify what you see on the road to protect not only the life of the driver but also the life of others around them. This is something that we would very much like to see the advances of our project being applied to. Now, I should also be clear here that our consortium does not work at this low level, low application level, I mean actually deploying integrated circuits and deploying these algorithms. This is something that actually other projects of the PEPR initiative are doing, and we are hoping to collaborate with them on this aspect. But this is one of the type of applications that we would really like to see our theory being deployed. Another would also have to do with, for instance, more reliability checks of fake news that we see, and the promulgation of fake news on Facebook or other platforms, etc., and being able to reliably detect what is fake and what isn't. Which is again something that has to do with the general scheme of a robust and reliable AI. For sure we're not here to get there, but we're hoping that with all the support that of the PEPR, we'll be able to make good strides in that direction. In several ways. One which is not directly related to the funding was the fact that the way it was conceived, it brought together many teams in France that even though we were aware of each other's existence, we never had an opportunity or the incentive to actually work together. And by putting us together in the same place, this really jump-started and accelerated interactions among us that have actually been very, very fruitful and productive in terms of research. Of course, the other main component is the funding provided, which has enabled us to recruit many PhD students that we wouldn't otherwise have the means to do so, and not only PhD students but also interns, research engineers, postdocs, etc. Liberate time for research for many members of the consortium. And the fact that this is not an isolated action, but it is part of a greater ensemble with other actions working together in a harmonized way towards a sort of unified vision, which we kind of share among us. Of course, we all have different perspectives, but the unified vision is there. This has been extremely helpful in guiding us forward.